Good evening, everyone. You're most welcome and thanks for joining us. Welcome to today's discussion with Professor Peter Thorne, a coordinating lead author of the recent UN Intergovernmental Panel on Climate Change 6th Assessment Report. I think it's fair to say its findings have had a profound impact globally in demonstrating the threat the climate crisis is already happening, and it's backed by indisputable science. It's been described as the final warning bell for planet Earth. My name is Kevin O'Sullivan. I'm Environment and Science Editor with the Irish Times, and I can assure you the climate crisis is increasingly dominating my work in covering the environment, and I think this evening will clearly demonstrate that when you hear what Peter has to say. But just to give you some detail of Dublin Climate Action Week, it is a week-long series of 70 online and in-person events. So there's a great mix to sample, and we recommend that you check in with the website www.dublinclimateactionweek.ie. This week is brought to you by Dún Laoghaire-Rathdown County Council, South Dublin County Council, Dublin City Council, Fingal County Council, CODEMA, which is Dublin's energy agency, and the Dublin Climate Action Regional Office. And its mission is to highlight Dublin's climate action progress to its citizens and to demonstrate the leadership that these local authorities are showing in conjunction with other partners. So we would like very much for you to participate in this evening. If you're tweeting about the event, you can share our tagline, #TakingActionTogether, and use the hashtag for the week, which is hashtag DCAW21. And a reminder that we have a question and answers session after the initial presentations, and we'd like you to participate. So if you submit your questions to the webinar Q&A, and we'll make every effort to get to them, but please put them in during the course of the discussion and the end of the presentation rather than at the end, so it gives us a chance to get through as many as possible. And I would particularly like to welcome Peter. Peter, it's great to have you with us this evening. And just to give a short bio in relation to Peter, he's director of ICRA's Climate Research Centre at Maynooth University, which is a phenomenal research facility on climate, which has a big international reputation, a great team working there. He was lead coordinating author on the IPCC 6th Assessment Report, which was known as the Working Group 1 report, to give its full and official title. He is co-chair of the Global Climate Observing Systems Atmosphere Observations Panel for Climate. He has been widely published, and he is an expert not only in climate change, but also on the issue of attribution, which is a really big emerging front in analysing the climate threat. Previously, he held roles at the UK Met Office Hadley Centre and at the US National Oceanic and Atmospheric Administration's Cooperative Institute for Climate and Satellites. So to start, I think it would help this event really is to outline how the process works in terms of the IPCC. So I think, Peter, that would be a good way of introducing your presentation then on the findings. So congratulations in the first place on the publishing the Working Group 1 report. It's a huge achievement in terms of climate science. So can you give us a quick run through on the significance of the report, especially in the context of the Paris Agreement, and how it was compiled and your role in it?
Okay, so IPCC reports are really something almost unique to climate science, and they're not your run-of-the-mill scientific papers that might be reported day in, day out. These are phenomenal efforts to perform holistic assessments of all of the climate science that has occurred between each assessment cycle. And then they're agreed in their summary for policymakers, which is what I will be presenting shortly. Those are agreed word for word, figure by figure, by all of the governments present in the approval. And it's a huge undertaking. It takes about 3 or 4 years. Normally there's a scoping meeting at which the outline is discussed and agreed amongst scientists, then that's adopted by the countries. And then typically you would have 4 lead author meetings where the authors get together and discuss and work out how to do the assessment in detail. There are numerous assessment cycles in there in terms of the review. It is the most reviewed piece of work in the field. We had over 100,000 comments across the 2 review cycles, and those need to be responded to review comment by review comment. This particular assessment cycle, of course, had a massive curveball put into it late in the day, in that we had to go virtual. And that was unique in IPCC. There were a lot of people saying you can't do this virtually. Not only did we complete the process in a virtual setting, missing one of the lead author meetings, but we also had the approval in a virtual setting. And that was a huge undertaking to get to that point. So yes, it's a massively important process. My personal participation in this round was as a coordinating lead author. That there are 2 or 3 coordinating lead authors of a chapter, and we're really responsible for the delivery of the entirety of the chapter. But even after that's delivered, we then go on to participate in the technical summary, and then the summary for policymakers drafting, and then finally we're involved in the signing off of the report as a whole. So it's a very substantial undertaking, which takes a huge amount of effort from a large number of scientists to complete. Scientists are selected from across the planet to participate in this activity.
Great. Well, that's very useful sort of starting out point. Thank you for that. Can you just one more clarification in relation to the Paris Agreement? This in effect stemmed from the Paris Agreement, isn't that right?
So the Paris Agreement, so UNFCCC, the process that underlies the Paris Agreement, called for the Intergovernmental Panel on Climate Change process way back in the day in 1980s. And this is the 6th assessment report, and the 2 have been intertwined throughout. So arguably the 5th assessment report, on which I was the lead author, was instrumental in creating the Paris Agreement. Now, there are interesting things about the Paris Agreement because it was the first time UNFCCC, the UN Framework Convention on Climate Change, specifically asked the IPCC to perform a report, but that was a special report on 1.5, and that was a huge undertaking in its own right, because that was they had 18 months to fundamentally say, is 1.5 even physically possible, and how do we get there?
Right.
Well, this working group report is the first in a part of 3, which will answer that question in much more detail. So watch this space. In February and March, there will be the further 2 working group reports.
Okay, brilliant. Well, thank you for that. That's really important background, and it illustrates how complex and thorough the whole process is. So I think, Peter, now if you present the main findings, because I think, as I was saying earlier, it just had an amazing impact in terms of recognition of the problem. So hopefully people attending tonight will get a fuller picture.
Okay, so hopefully everyone can see this presentation, and solely this presentation. Please let me know if that's not the case. So I'm going to present here a subset of the summary for policymakers, figures and findings, and it is just a subset, and that's a subset of a much greater piece. The whole PDF is about 4,000 pages, if you really want to read a lot. So, recent changes in the climate are widespread, rapid and intensifying, and they're unprecedented in thousands of years. And that's a really key starting point to our understanding. The changes we are seeing are not normal in any sense of the word. We can go to the very first figure in the summary for policymakers to look at this in more detail. So this is global surface temperatures. Across the horizontal axis is time from basically year zero or year one through to present. The black line at the very end is the directly observed temperature change. Now, we don't have thermometers 2,000 years ago, but we do have things that act or co-vary with temperature, things like tree rings. So we can use those to reconstruct the climate back over millennia. And what we see in the main panel here is that the warming we've directly observed in the last 170 years is just off the scale different to anything we experienced in the last 2,000 years globally. Now, on the left-hand side here, you'll notice a little bar. That little bar is the warmest it got in the present interglacial. So Earth's climate has gone over the last 2 million years through glacials and interglacials consecutively. The present interglacial, our best estimate of where that warmest point was about 6,500 years ago, is about 0.2 to 1 degree warmer than pre-industrial. We are now 1.1 degrees warmer than pre-industrial. That means that fundamentally we have now exited the climate space in which we developed from hunter-gatherers through an agricultural revolution, through an industrial revolution, and a technological revolution. We have pushed the climate in a fundamental way outside the safe operating space in which we have developed and thrived. And we know it's us. This is the second part of that same figure. We have massively complex computer-based simulations run by multiple groups, including iCheck in Ireland, amongst many, many others internationally. And there are two sets of runs of these simulations that are part of an international coordinated modeling effort. They simulate the past from 1850 to present, and they simulate it using two different sets of assumptions. One is that the climate was only forced by natural variability, the sun and volcanoes. The sun is the energy system of the Earth. It varies. Volcanoes, when they go off and they're very large, act like effectively weak parasols on the Earth's system, deflecting incoming solar radiation, cooling the planet. That's the green. The browny orange is those same simulations, but now we're adding in human influence. We're adding in carbon dioxide, methane, N2O, other greenhouse gases, also aerosols. That's not the stuff you spray in your hair, that's small atmospheric particulates. The black line is the observed changes. And what you see is up till about the middle of the last century, you could explain what was observed just by those simulated natural effects. But in the last 60, 70 years, you just cannot explain how the climate has changed without invoking that human influence. We can look at this using formal detection and attribution studies. So here, the very left bar is that observed warming of 1.1 degrees roughly. And when we break it down, when we work out what the contributions from human and other forces are, well, the total human influence basically matches the observed warming. So when someone says, well, how much of the warming is due to us? It's all of it. But actually, when you break that down, our greenhouse gas emissions have led to a warming of about 1.5 degrees, which has been counteracted to an effect by the other human drivers, those aerosols, those particulates. There's basically no contribution from solar and volcanic or internal variability. So this matters hugely. One of the reasons it matters is that different components have different life cycles. So those aerosols typically stick around for 2 or 3 weeks. whereas those greenhouse gases stick around for decades to millennia. So it's really important that we understand what is happening. It is indisputable that human activities are causing climate change, making extreme climate events, including heat waves, heavy rainfall, and droughts, more frequent and severe. This is a major innovation in the 6th assessment report. We are really saying that we can pinpoint human activity as an influence on these events. We came up with these really cool hexagons that look a bit like the world but give equal weighting to different areas. We're the one called NEU in the middle top, Northern Europe. This is heat extremes. Hot extremes are becoming more likely wherever this is red colored. And there's very high confidence where there are 3 dots underneath. So you'll see that across Europe and Asia, there is very high confidence that hot extremes are becoming more likely as a result of human influence. There are some grey ones in, say, sub-Saharan Africa. That's where we simply don't have the data or don't have the analyses to support making an assessment. But pretty much everywhere across the globe, with the exception of parts of North America, heat extremes have been made more likely due to human influence. We can do the same for heavy precipitation, and you'll notice here a lot more grey hexagons. That's a lot more areas where we don't fundamentally have the data or the analysis to make an assessment. But where we do have the data to make an assessment, heavy rainfall events are becoming more likely. And you'll notice that Northern Europe is the one with 3 dots under it, which means there's high confidence or very high confidence that in Northern Europe, extreme rainfall events are being made more likely. Just think about Belgium, Holland, and Germany this summer to see that in reality. But we also have history in Ireland of this, the Long River Shannon flooding from Storm Desmond, the Donegal floods. So we know we have a problem. Can we do anything about it? Well, to limit global warming, strong, rapid and sustained reductions in carbon dioxide, methane and other greenhouse gases are necessary. This would not only reduce the consequences of climate change, but also improve air quality. So one of the things to be clear about is that climate action can have win-wins. The big beast, the thing we absolutely must get to net zero is carbon dioxide emissions. We currently emit globally about 40 gigatons of carbon dioxide a year. That's a heck of a lot of carbon dioxide. We can't run model simulations with everything. So you'll see in this and a number of following slides, these 5 scenarios. They all take different socioeconomic assumptions. And what I want you to concentrate upon in these is the 2 blue curves, SSP1 2.6 and SSP1 1.9. SSP1 means global cooperation, and the final number means the radiative imbalance at the top of the atmosphere at the end of the century. But what you'll see here is that both of these drop carbon dioxide emissions to 0 at or around mid-century and become net negative thereafter. That means we're drawing down carbon dioxide from the atmosphere, either through natural or through anthropogenic mediation of the carbon cycle, carbon capture and storage. Methane has an outsized influence on Irish climate policy. Again, there are a range in here. The colours are exactly the same mapping. What you'll notice is that those 2 blue curves, as well as reducing carbon dioxide rapidly, also reduce methane rapidly. Global methane emissions are reduced to about half by 2050 and continue to decline through the balance of the century. And you get pretty much the same story with nitrous oxide. So they're the 3 large major greenhouse gases. In those 2 blue scenarios, they all decrease much more quickly and stay decreased, declined relative to all the other scenarios. And sulfur dioxide, those aerosols, also decline more rapidly in those. Why is that important? Well, here you're seeing temperature against the end of the century. The colors are the same here from left to right. We go from the very low emissions scenario to the right-hand side, the very high emissions scenario. The three curves on the right-hand side of each are interesting scientifically, but what I want you to concentrate upon is the very left-hand bar in each. So the temperature range here is from 0 to 6 degrees centigrade. And the warming we have seen to date, that 1.1 degrees, is color shaded a bit darker. So that's what we already have committed to. That's what our historical behavior commits us to. The lighter shade above it is what those emissions that we just saw in the last 4 slides would commit us to in terms of additional warming. Now, remember that the Paris Agreement articulates an ambition to keep temperatures well below 2 degrees centigrade and strive to retain them below 1.5 degrees centigrade relative to pre-industrial. Well, SSP 1.1.9 just about keeps us under 1.5 at the end of the century. In fact, it goes slightly above and then comes down below, but that's low overshoot is the technical term for that. SSP 1, 2.6 keeps us below 2, but does not meet the 1.5 ambition. Every other scenario takes us well above 2 degrees centigrade by the end of the century. So the key thing here is that if we're going to have a hope of meeting those carbon, the Paris Agreement targets, we need fundamentally to drive carbon dioxide to net zero mid-century and net negative thereafter. And we need substantial and sustained and immediate reductions in the shorter-lived methane and N2O forces. So climate change is already affecting every region on Earth in multiple ways, and the changes we experience will increase with further warming. The very first thing to note in this is that in the top row, we have 2 maps. One is what we've observed, and the other is what we simulate at 1 degree centigrade. And you really have to play to an extent spot the difference. And this speaks to the quality of the simulations that we have. There are also common features that we see. The Arctic warms fastest. The continents are warming faster than the oceans. There are some parts of the oceans that warm very little or even cool slightly. And we see those patterns basically scale with warming. So this is the temperature is something that scales with the warming. The pattern of the temperature changes we might see scales with warming. And Ireland might well get away with it reasonably well for this, for temperature. There are areas of the planet that will warm substantially more than the global mean. Most of the areas that will warm less than the global mean are the oceans, where very, very few people live. We can look at precipitation change. How much will the precipitation change? So that's rainfall, snowfall in the high latitudes. And what we see is, again, this scaling where what's happening now or what's going to happen at 1.5 just gets worse. Look at, for example, at the Mediterranean basin. The Mediterranean basin just gets drier and drier and drier with additional warming. And that gets exacerbated because soil moisture is the balance between precipitation and evaporation. As you warm the atmosphere, it can carry more moisture, you get increased evaporation. So soil moisture is telling us something really interesting about how things change. You see the Mediterranean really dries out very, very considerably. You also see, concerningly, drying out of, say, Amazon rainforest basin. can the Amazon survive a 4 degrees warmer world is an interesting question. But it's not just the mean changes that matter, it's also the extremes. And extremes are changing, becoming more likely quicker than the temperature is increasing, and are also in many cases increasing faster. So at present, at 1 degree C of warming roughly, what would happen once every 10 years now happens about 3 times more likely. So what happened once a decade now happens roughly 3 times a decade. Not only that, but it's 1.2 degrees hotter, not 1 degree hotter, and that goes up. But the other thing is, if you come to the right-hand side of this plot, you see that it gets even worse at a 50-year event, a 1 in 50-year event. And what this is telling us is that the tails of the distribution, the real extremes, are becoming more likely and more intense. And you just have to look at the Pacific Northwest heat wave this summer to see that in action. Precipitation, heavy precipitation over land also becomes more likely and substantially larger. We already have about 7% wetter extreme wet events. So that flooding in Donegal a few years ago, more likely and more intense because of human influence. And this will get worse and worse and worse. What you see and hear is that there is a degree of non-linearity to this. So it really will matter. So there's no going back from some changes in the climate system. It's a really important point. There is a multi-generational aspect to climate system. However, some changes could be slowed and others could be stopped by limiting warming. So what do we mean by this? Well, let's start with the iconic global surface temperature. And this is one of those things that could be halted within our lifetimes. If we get our act together and we follow those SSP1 scenarios, those blue scenarios, both of them stabilize temperature within this century, within many of our lifetimes. That's because temperature responds very, very quickly to any radiative imbalance in the climate system. The same thing happens with sea ice. Again, those 2 blue curves here in terms of September Arctic sea ice area stay above stabilize within our lifetimes, and we can probably avoid, at least on an annual recurring basis, practically ice-free Arctic conditions. Global surface pH for the ocean acidification, which has huge implications for ecosystems in the ocean. Again, we can stabilize within our lifetime. But there are things we cannot stabilize within our lifetime. Global mean sea level change, both those blue curves are still beautifully gliding upwards in 2100. There are also very uncertain processes that mean that we don't have a good handle on the upper end of the distribution. So we can't rule out more rapid sea level rise. We're not talking tens of meters, but we are talking more rapid than the central estimate by 2100. But where it really starts getting scary is when we look out to 2300. So this is what we're giving multiple generations hence as a headache at this point. So SSP1 2.6, one of those 2 blue curves, 2300 sea level could be anywhere from 0.5 to just over 3 meters higher. Whereas SSP5 8.5, the very high emissions scenario, could get us much, much higher, much, much quicker. So this really matters. So unless there are immediate, rapid and large scale reductions in greenhouse gas emissions, limiting warming to 1.5 degrees centigrade will be beyond reach. And this is the very final slide. This is where we will be in 2050. So along the horizontal axis is the amount of carbon dioxide we will have emitted. And coming up on the vertical is how much it'll warm. We've emitted roughly 2,500 gigatons of CO2 to date. We're at 1.1. Really, where we want to be in 2050 is up to us. If we act with extreme speed, we can limit warming to 1.5 within our lifetimes and start to return it towards pre-industrial by the end of the century. And that's the end of the presentation.
Thank you very much, Peter. That was a superb overview, and really it was very accessible as well, I think. So we're grateful for that. Like shocking in many respects, but also you have highlighted repeatedly where human influence can come for the good. So it's the questions are beginning to come in, but I'm just going to ask you a personal question first to kick it off. Describe your reaction when you got it over the line. Like there's a lot of negotiation, as you say, word by word, sentence by sentence, and then you have to get agreement from governments and members of the IPCC. So that must have been a great sense of relief when all that was nailed down.
Yes, it was indeed a great sense of relief. We were taking bets on it happening kind of on Sunday. It was scheduled to finish on the Friday morning. And we were all certain it was going to go on for a long time. And suddenly a whole load of issues resolved. And we ended up on the Friday. So it was a little strange because we thought we would be going longer, and then suddenly it was all resolved. But yes, when the gavel starts moving down, it starts getting, as an author, exciting. It's seeing the delivery of something that you've worked on for 3-4 years.
Yeah, great sensation. I've no doubt. To kick off with the first audience question from one attendee. Does the success of producing the IPCC report virtually present not only a precedent, but remove barriers to collaboration and the production of other significant reports going forward?
That's a really interesting question. I think we were lucky in when we went virtual. In working group 1, working group 2 will be similar. Working group 3 was a little less fortunate. We'd already had 3 meetings. We'd already had the chance to really form the teams, form a common understanding. Now, I'm also a section facilitator for the synthesis report that will wrap the whole thing up next September. And I would say we're having huge challenges there because we have started that process virtually. And there has been no opportunity to do any kind of team building other than via Zoom. So I think it has proven that certain things are possible. I'm not entirely convinced that you could produce an entire IPCC report virtually. But I think it has proven that many of the assumptions that we made, and those go much broader than IPCC, about ways that we have to work to be effective, have been challenged by what we have had to go through collectively as a global society these past 18 or so months. Right.
Well, thank you for that. And so just to talk about, the reaction on this occasion, global reaction, and even in Ireland, was a lot different to previous IPCC reports, in my view. It had such a profound effect. Do you think this is a game changer and it's going to galvanize more and better collective action?
It certainly gives the opportunity to galvanize more collective action, but equally it lands in a context of a world that is struggling to overcome the first global pandemic in at least a century, depending upon how you define them. It has landed with good overall coverage. The key messages clearly landed and resonated with people. I think much of that is due to the graphics, some of which you saw in the presentation, which I think huge efforts were made to make them more accessible and usable by a variety of actors, media included, but not solely the media. So I think it has made a degree of difference. We wait to see what happens with these other two working group reports that will appear in spring, late winter, early spring of next year.
Very good. And just to introduce a little bit of controversy, you questioned some of the interpretations of the report in Ireland, and particularly in relation to methane. Can you expand on that? Why did you intervene? Were you concerned about certain viewpoints?
So the Irish Farmers Association released a press release that was based upon half a sentence buried deep in a chapter. The half a sentence implied that we overestimate the impact of sustained methane emissions. The next half of the sentence goes on to say, and at the same time, we understate the influence of any new methane emissions. Now, of course, Irish agricultural methane emissions have increased in the past decade by in excess of 10%. Also, that ignores the strong language endorsed by all the governments around the need for strong, sustained methane emissions. I do not believe fundamentally that the agricultural community is well served by being given misleading information that is not indicative of the balance of the report. I have huge sympathy for the agricultural community and the challenges it faces. I also have huge respect for their ability to innovate, and I believe that given the right market forces and policy nudging, that our agricultural community can not just survive but thrive in a lower carbon economy. We need to get this right. We need to have a just transition. Okay. Rural Ireland cannot be left behind, but telling them it's all okay when the report balance says it's not is not the way to do that.
Very good. And there's a number of questions coming through on the whole issue of 1.5 degrees, which I'll come to in a moment. But just to say to the audience, you can give a thumbs up to certain questions, will be pushed higher up the list. On the 1.5, I just wanted to ask you, there are those, we all know, it's linked to possible climate tipping points, dangerous tipping points where we lose control of certain things and cascading effects kick in. But if you were weighing up, and you've made very clear distinction between the different scenarios, but is 0.5 limiting to 1.5 degree, is that realizable at this moment, given the amount of evidence you've unveiled in this report?
It is still physically possible to limit warming to 1.5. Whether it is technically and societally feasible is a question that other working groups, particularly Working Group 3, which will appear next March, will go on to answer. What we could say in Working Group 1, the physical science basis, is be clear that depending upon the choices we make, we are not committed to fundamentally breaching 1.5 in the long term. In fact, that SSP 1.9 scenario, that very low scenario, does reach 1.5 and slightly exceed it for a short period of time, but it pulls us back below 1.5 by the end of the century. So that's the limit of what Working Group 1 can say. Working Group 3 will look at hundreds, if not thousands, of possible scenarios and look at what that would mean in terms of temperature. So we will be able to give you a much more comprehensive answer on that after the Working Group 3 report is released in March, and we will try and communicate that in the synthesis report, which will follow in September. And
correct me if I'm wrong, but I think there will be a lot of emphasis on solutions, won't there, in those final reports next year?
Yes, so the working groups, so Working Group 1 is the physical science basis. It's basically the health check on the climate system. How well do we understand it? What is the diagnostic of the patient? Working Group 2, which will appear in February of next year, is about impacts and adaptation. What do we understand that means for society, for nature, for infrastructure, for a whole host of things? And how might we adapt to it? Are we adapting effectively? And then Working Group 3 is about mitigation. It's about what are the pathways that we could plausibly follow. So it's not saying go and live in a cave tomorrow. It's saying, well, can we stop emissions very, very quickly? What does that world fundamentally look like? What do we have to do? How do we get that solution space? So yes, Working Groups 2 and 3 are all about the solution. And it's key to not forget about adaptation. We chase mitigation, but adaptation, we already are experiencing extremes in climate that our infrastructure is not built for, and that will get worse. And we must take adaptation seriously.
Okay, I hear you on that. We have a question here from Fiona English. What is the latest thinking on the activity of the Gulf Stream and potential impact on Ireland? And I know you mightn't have referred to that in the report, but clearly some of your findings will impact on that.
Yeah, so we did cover the Atlantic overturning circulation, the Gulf Stream, and the North Atlantic Drift. Very recent observations do show a decline, but there's relatively low confidence in that being a long-term signal and not kind of decadal variability. The climate models do suggest that if we continue to emit greenhouse gases, the overturning circulation will slow down. Now, we do have a novel aspect of the Working Group 1 assessment report is looking at low likelihood, high impact outcomes. And one of those low likelihood, high impact outcomes would be a complete collapse of the overturning circulation. We have medium confidence, which has a particular meaning in IPCC about how much evidence and the degree of agreement of that evidence in the fact that the overturning circulation will not fundamentally shut down this century. That means we can't rule it out.
Okay.
But we're pretty sure it won't.
Right. That's
so yes, there will likely be reductions in the overturning circulation, but it is unlikely within this century that it will shut down. We can't rule it out.
Okay. We have a number of questions on COP26 in Glasgow in November, and I know you don't want to comment on policy issues, but we have one particular question from Charles Sapwell. What are your hopes for COP26 outcomes?
So, I'm still uncertain what COP26 will physically look like, whether global equity concerns will be met in terms of allowing access to all parties. So I'm not even sure what COP26 will look like in reality. The COP process must yield progress. We cannot afford to have the international framework break down. So there must be continuous progress. I would expect a number of countries to make new nationally determined contribution declarations as we go into it. But a lot of this is about actually making change happen. Saying you'll make a change is much easier than making a change happen. People are inherently conservative with a small c. We inherently prefer the status quo. I see lots of reticence about things like battery electric vehicles. How could I refill? How could I get to Donegal? How would the chargers work, etc., etc. The same with things like moving to heat pumps. There is a lot of reticence because it's the unknown, and we've got to break that down, and we've got to help society to transition to low carbon futures if we're going to have a chance. So COP can do a certain amount, but then it's down to national governments, it's down to regional governance, it's down fundamentally to communities and to you and me and everyone else.
Very good. Well, I think that's a very telling observation on what needs to happen, and hopefully there will be a meaningful COP in the first instance in terms of participation and a move to go beyond just the finding that you have in your report to a greater sort of action phase, because clearly the clock is ticking. So we have another question here, paying tribute to your work, but also asking a science communications question. Isn't it a huge mistake to use again and again the 1.5 degrees or 2 degrees increase as the main message to the general public? The average Irish person's brain is craving for sunshine and heat, so thinks it's not so bad, and they hear the catastrophic predictions, but they choose to resolve the cognitive dissonance with what seems to be more acceptable for them. Couldn't another clearer language be used? Now that's a very big question.
Yeah, and that's why in the main report the 1.5 and 2 degrees is not really mentioned, but 1.5 and 2 is the international policy framework. It is the Paris Agreement for policy relevance. It needs to be there. But no, our key messages are that climate change is happening. The change we're seeing is highly unusual. In thousands and thousands of years, we're exiting the safe space we've developed. We are seeing more and more extremes. Those extremes, in particular of temperature, precipitation, and drought, are being made more likely by human influence. And it will get worse everywhere, but we can make a difference. We can stabilize the climate system, or aspects of the climate system, within our lifetime. But then we need to be honest that there are aspects of the climate system that we have put in train that will go on for a very, very long time. Sea level rise requires, to stabilize sea level, will require both the oceans, which have about a 2,000-year circulation time, and the great ice sheets, which arguably have never been in equilibrium, to catch up. And that's 2,000 to 10,000 years. So we have set in motion a problem for multiple generations. Hence, last time temperatures were sustained at the present level, sea level was 5 to 9 meters higher than today. The last time carbon dioxide was at the level of today for a sustained period, 3 and a bit million years ago, sea levels were anywhere from 5 to 25 meters higher than today. We really are staring down the barrel in terms of long-term committed sea level rise, and there will be very difficult choices, not for us, but for future generations around our great cities on this island.
Yeah, that has very clear implications for Ireland, no doubt about that. I have a question here, and I hope I'm pronouncing the name correctly, from Cheng N. Yang. How would you explain the increasing mean precipitation changes in Central Africa and Central Asia? Will desert regions benefit by warming?
So those maps are in terms of the standard deviation of the precipitation. So that's how much the precipitation varies year on year. So those are actually very small absolute changes in the precipitation. And they are dwarfed by the temperature increases, or largely dwarfed by the temperature increases. So that's why the soil moisture was important, because how much moisture there is available to vegetation is fundamentally that balancing act between temperature and precipitation.
Very good. Thank you for that. And just turning to Ireland now and the whole concept of carbon neutrality by mid-century. And clearly we have committed to that target, but does that mean we have implicitly committed to greenhouse gas removal? And if that is the case, can you outline what that entails and what kind of measures would be necessitated?
So yes, net zero does fundamentally differ from zero. Zero would mean absolutely no emissions. And Working Group 3 will make clear, but I can state from just personal view, we won't get to zero emissions. We can reach net zero emissions. And net zero emissions means we're drawing down more carbon than we are emitting. And nature has developed ways to draw down carbon. It's been very clever at it for millions and millions of years. It's photosynthesis, it's things like peat bog formation. So ways that we can make nature work to be a net sink are things like afforestation, re-wetting wetlands, restoring peat bogs. Those fundamentally will change what are currently sources in many cases into sinks. But carbon capture and storage will be probably required. That's technologically drawing down carbon. It is fundamentally unproven at scale at the present time. I think there was a new plant that opened in Iceland about putting carbon into rocks last week that would draw down about a week's worth of an American city in a year. To give you a flavor of the scale mismatch between where that technology is today and where it needs to be, and implicit in those two blue SSPs, SSP 1, 1.9 and SSP 1, 2.6 is broad scale carbon capture and storage. So we need to work on that technology, but at the moment it feels a bit like nuclear fusion. It's always 30 years in the future. We cannot rely upon it. We cannot delay and dally on reducing emissions today in the hope that carbon capture and storage becomes viable at a reasonable cost in the future so we can draw down what we emit today. We absolutely need to get on top of emissions today. It is the only option.
Very good. We have another question here from Marianne Harris. Why do you call carbon dioxide the big beast? Is methane not a potentially greater problem per ton? Given population increase and demand for food, methane continues to be a challenge.
Yes, so methane, well, carbon dioxide is the problem because carbon dioxide fundamentally has no recognized half-life. Carbon dioxide sticks around, much of the carbon dioxide we emit will stick around for tens or hundreds of thousands of years unless we can mechanically capture it. So if we don't chase carbon dioxide, we don't fundamentally ever stabilize climate. We must stop net emitting carbon dioxide. That's the only way we stabilize the climate system. So carbon dioxide, if you like, is a stock forcer. The more we put in, the more it just sits in the atmosphere. Methane, and to a lesser extent N2O, are flow forces. Methane has a half-life of about a decade, which means if I put a ton in today, in a decade it'll be half a ton, in 2 decades it'll be a quarter of a ton, etc., etc. So by the end of the century, effectively none of that methane remains. So if we aggressively address methane, and this is why we need to aggressively address methane, we can slow the warming in the short term. That fundamentally reduces the short-term warming, reduces the short-term impact. As you would have noted in the attribution diagram, current greenhouse gases commit us to 1.5, masked by the aerosols, by the small particulates. We have to reduce methane to keep below 1.5 degrees. Both of those blue lines for methane halved emissions by the middle of the century and kept reducing them after. That's the scale of the challenge. We cannot continue to look at this. But methane is almost, methane is from fossil sources, from rubbish, breakdown in refuse, and from agricultural, both rice and ruminants. And changing our diets, changing the requirements for ruminants can radically reduce methane in the short term.
Okay, thank you for that. So we have a question here from Brian Eddy. Which countries are leading the way in achieving greenhouse gas emissions reductions and achieving net zero in terms of the likelihood of meeting that 1.5 degree target?
So there are a number of countries that have led the way for a variety of reasons. There are countries that arguably have led the way largely due to serendipity, such as the United Kingdom, which went from coal because Margaret Thatcher wanted to break the National Union of Mine Workers to gas. And that explains much of their reduction. Now they've gone then to wind, etc. Denmark is probably very good, but there are no countries, or very few countries, that fundamentally are meeting the scale of the challenge we need. Working Group 1 can make clear that it's physically possible. Working Group 3 will go on to look at what would be required, but it's pretty clear from the way that emissions are going globally and for most nations that very few, if any, nations are on track to meet the ambitious targets required to keep us to meeting the Paris Agreement targets at this current time. So we need a ramp up of ambition. Technology exists to fix it.
Right. Okay, well, I know I know that sounds very negative, but in your earlier presentation, you highlighted, the positive options. For people watching this evening, is there something, tangible that you can tell them to give them a sense of optimism rather than to be overcome with a sense of doom?
So we're unique as a generation for knowing the nature of the problem. We're also unique as a generation for having the opportunity for solutions at this time. 2 decades ago, solar and wind power were horrendously expensive, not competitive with others. Equally, we know that there are solutions and opportunities in many, many different spaces. So we are uniquely empowered as a generation. We know there is a problem. We know that there are many solutions, and we see year in, year out, more and more solutions being made coming to the marketplace. We are ingenious. We have the opportunity. We can grasp it. We must grasp it. So that's what keeps me optimistic. Knowledge fundamentally is power.
Very good. Well, I think we're coming to the end now, and that's a very good, inspiring note to keep in our minds. And hopefully everyone this evening who has joined us has a better knowledge, not only of your report, but also of the whole issue of the climate crisis and the threat that already exists, and the extent to which we have choices in the coming years, even though the timelines are extremely tight. Just one last question for you, Peter. You're a member of the Climate Change Advisory Council. Can you explain what that entails and what's likely to emerge from your deliberations in coming months?
I can give some flavour of that. So the Climate Change Advisory Council is really the independent body that provides advice to the government on all matters of climate change. Under the new Climate Change Act, it has increased powers, including the setting of carbon budgets, or the recommendation of carbon budgets. Their actual adoption is a matter for government, and the matter of sectoral carve up of that budget is certainly a matter of policy and therefore government. We have a huge amount of expertise within the council, and we can call on multiple additional experts who have provided immensely valuable information. So it's an exciting time in Ireland in terms of climate, because with the Act we have fundamental governance. We have made climate an all of government problem, not a Department of Environment and Climate Change problem. We have made it such that there is a standing committee of the Houses of the Oireachtas to hold the Secretary General's feet proverbially to the fire, and we have a much strengthened Climate Change Advisory Council that has real teeth to provide the advice that is required in an impartial way to government. So I think there are exciting times to see real step change in ambition across government and across the country at this time.
Very good. Well, we'll be watching your verdicts and recommendations in coming weeks with avid interest, and likewise with the next stages of the AR6 process with the Working Group 2 and Working Group 3 reports early next year. So thank you very much for a really enlightening presentation and commentary this evening, Peter. We're very grateful for that. And I'd also like to thank our attendees and for your questions, which were very gratefully received. I'm sorry we didn't get around to all the questions, but I think we've had a very good exchange. Just to remind you that this webinar will be up on the Dublin Climate Action Week's website in due course, and also to urge you to participate in the week by tuning into different events, and there really is a fantastic mix of things to do over the coming week. I'd like to thank Dublin Climate Action Regional Office for organising this particular event, and the only thing is to wish you well and say good evening. Thank you very much.